All right, so I wanted to talk to you guys about effective nuclear charge and principal energy levels. And as you can see, the title of today's notes is Zeff. Well, Zeff is known as effective nuclear charge. Why do they call it Zeff? Honestly, I have no idea. Maybe because effective? I'm not sure. But so effective nuclear charge is essentially the attraction to the protons. Because remember, our protons are positive, and our electrons are negative. And so it's kind of like a battery or a magnet. They are attracted to each other. Opposites attract. So that's what's happening here with effective nuclear charge, is the pull of the nucleus to the valence electrons. Okay, and then I wanted to talk to you guys about principal energy levels. And we've talked about this before when we learned about electron configuration, but I'm going to abbreviate it today with PEL, principal energy levels. And these are just the shells of the atom. We've also called them N. So for example, if this was an atom, this would be N equals 1, and then this one would be N equals 2. So it's just the number of rings or shells or energy levels that an atom has. So I want to connect this to what we already know about the periodic table. So here we go. Here's our periodic table. Whenever we go down the periodic table, the thing that impacts every single trend is the principal energy levels. So the number of rings that an atom has is what has the biggest impact on the trends as we go down the periodic table. Now, as we go across the periodic table, Zeff affects all of the trends. So the effective nuclear charge, or how many protons are there. Because as we go across the periodic table, we have an increase in the number of protons, meaning we have a stronger magnet. There's more pull to the center, causing the atoms to get smaller. So recall that atomic radius, I'm going to abbreviate that AR, decreases as we move from left to right. Ionization energy increases as we go from left to right. And then electronegativity, increases as we go across the periodic table from left to right. All because of Zeff, effective nuclear charge. Now, when we go down the periodic table, the atomic radius will increase. Ionization energy will decrease. It takes less energy to remove an electron because the atoms are getting more and more spread out, so it's easier to just remove one of those electrons. And then lastly, electronegativity will decrease as well, all because of the principal energy levels. Okay, I hope that makes sense, and I hope that helps everybody out. And I will talk to y'all next time. Bye-bye.